Mhm. Ah, yeah.
Hey, David. Hey,
Mhm.
Mark.
Hi.
Hey, Vikas.
Hello, can you hear me, James?
Yes, I can hear you. Hi.
Okay, perfect.
We wait for a few minutes. I think I for others to join. So yeah. Hey, Roger. Hey, Poon.
Hi, James.
Hey,
Morning.
good morning. Um, Why are you joining? Let me share my screen. Um,
Hey guys.
Hey, Tony. Can you see my screen?
Yeah.
Yes.
Okay. Let's share that. So, all right. Yeah, before we start, I think like I think we do have new member here. I think Vikas, thanks for joining. I think David has introduced. I think I talked, okay, mentioned that you'll be joining. It's very great to see you here. So I assume Vikas, you're coming from maybe a big quick like intro for yourself.
Yes. So I recently joined I, and I am actually looking uh, uh, to first of all like learn what are the standards. I'm the standards person over here to come up and go over what has been uh, already discussed, and a lot of the documentation and everything is very, very useful. And still getting a hang of it, like what are the challenges and things like that, the methodology part. So,
Got it.
and
Okay.
yeah, and and then over the period of time, how we can actually, when we are fabricating, what all we need from our side, how we can be uh, uh, develop this into a good partnership. So
I see. Okay. Yeah, appreciate that. Thanks for joining here. So um yeah, I see other folks are joining like Rudy. Like yeah, I think for um yeah, this is yeah one of the 3DK meetings that we had. I think focusing on assembly design. Hopefully that will be useful for you. I think I just for quick start the meeting, I just want to um do a quick thing from previous meeting, especially for those was not there previously. This is the document I think we use for tracking. I think we create this document. Let me share that again in the um chat windows here. And also like I will send that in the group meeting if any of you haven't joined that group IO. I think especially for the newcomers. So please feel free. I think I definitely should join that so that we can we share our information there. So here's a notes. I think the document that we're creating, I think based on the discussion that we have, and also like part of the um structure, I think I share right by Intel. So like for the assembly design rules. So, and here's a statement from the last few meetings. We kind of like looking to get the very first version of these documents to be ready for the global summit. So we will mention and about this, and then hopefully we can get something. Talk to David. Hopefully we can get something. I think ready. I think for the OCP. I think later this year. So here the scan state. I think we hope everyone in the group here can review this. And then we also talk about, I think there's some subtracts and RDOs and rounding rules, that kind of bending rules. So hopefully I think we can add that in the next few meetings. That's why we kind of put a target there in November. So, and then there's some SMB rules I think I shared by the SC. I think we can potentially also add that into the when we start defining some of these subset rules, you can add this one as an example here. And yeah, I think that's kind of like the status then. I think I've seen the last meeting. Anyone has any questions or anything more that you want to add or discuss over?
So James, we had a discussion, I forget earlier with David about potentially splitting up the pin rules, for the placement of the bump placement, the connectivity type rules from the more routing type rules and implementation rules, just to because there really is a different usage. So the idea with the connectivity rules, they're focused strictly on the interconnect between the different components in the package, and they don't really get inside the components, whether it be the substrate, interposer, or chiplets. And so
Tony, can I have ask a question as you go along there? Those
Yeah.
interconnectivity rules that you're referring to, are they like the maximum Manhattan length between this component and another component based on the specific terminal output?
No, that's an even additional set of rules that falls more into the general purpose DFM type rules. So
when you mention their interconnectivity rules, what do you mean? Give me an example.
It's specifically related to the rules that affect the interconnect between the different components. So it's really the pin placement. So when we're assembling a package, you need to know where all your pins and TSVs are. But really, the routing is kind of considered inside either the chip or the interposer or the substrate. So the idea is these rules would be used predominantly for assembly, and then the other rules that get inside of the chips would be used to actually build those components, whether it be an interposer. We're not going to be building chips. I mean, we already have chip rules, but TSMC and other fabs typically have a separate set of rules for just like, for example, the micro bumps that for a chiplet that really are kind of independent of the rules for the guts of the chip.
So the way Ballard,
I think you're actually the one who, if I'm not mistaken, you're the one who brought that up.
Yeah. So I probably explained it a little bit different in a more PCB language type of thing. So on each chiplet, you have all the bumps. How do I connect those bumps to the it's interposer. So you have the bump to the pad on the interposer connectivity.
Well, they're connected by abutment. I mean, they just, you know, that's why you need the compatible rules, right?
Yeah. So to me, that's one rule set, right?
Right.
Then a different rule set is, how do I connect a route from one bump to the next bump, irrespective if that bumps are on the same die, or if they're irrespective if they're going between one die and another die. And that's everything to do with routing rules. That's another set of rules, and it should be separate from the first set of rules.
Correct.
Right. Okay. Good. Okay. Where does the rules, like, I need to have the minimum or maximum distance between on a particular route in order for the electrical performance to work? Where does that type of rule fall into?
I'm sorry, say that again.
I need to have a maximum distance on the route in order for the electrical performance to work.
This is Michael. That is a design
It's a design constraint.
decision. It's not manufacturing constraint.
It's not a
Right,
manufacturing
so-
constraint. So you're only
it's not.
focusing then on manufacturing constraints.
So there's kind of two
Correct.
classes of rules. You know, one is for design for DFM. Those are not manufacturing rules per se, but they are, you know, one way you could phrase it is they're guidelines or best practices that will give you, you know, better yield. And then a similar type class that will give you better electrical or whatever kind of performance, you know, possibly even thermal, who knows. So those are more design centric or yield type rules. They're not manufacturing rules. And
Okay.
So the manufacturing rules would be coming from the manufacturers. Some of them may provide, you know, some of these other types of rules that I talked about, but, you know, those are rules that you know, the manufacturing, if you don't follow those rules, they're not going to accept the database and they won't manufacture it. So those are enforced rules. The other ones are really up to the system designers as to whether or not, you know, those are hard rules or guidelines or principles. So we just, you know, just lumping them all into ADKs, I think we decided that, you know, ADK kind of is more of the first type that we talked about, the connectivity type rules. And that's what most people think about when they use that term. And that's pretty much what 3D Blocks is targeting. But we are looking to expand the scope to cover these other types of routing rules and DFM and electrical type rules. So we need to come up with some nomenclature for that, and also how they're going to be structured.
Okay, so I have another question, and I agree with what you said there, Tony. That makes absolute sense. I have another question for you. Suppose you get a chip from Micron, a memory module, a HBM from Micron, and Micron states that the design constraint on this particular terminal needs to be a certain shape or a certain length. Where does the rule that they specify for their die that is going to be implemented into any design, where does Micron rules for that die go?
Well, I mean,
Say that again.
These rules are extensible, so you can create whatever rule you want, you know, as a designer. But I guess in principle, the manufacturer can also define those rules and guidelines as well.
Yeah, the manufacturer of the chip, to say that if you want to use my chip in any design, you must comply with my rules. And the interposer will say, you must comply with my rules. And so the ultimate person that's designing the assembly, he has to comply with a whole suite of different rules coming from different sources.
Should we differentiate between a rule and a guideline?
Yeah, that's what I was thinking is
The
that
rule must be enforced, right?
yes.
Whereas other things, it's at the discretion of the manufacturer and or the designer
That's right.
to bend or waive or, you know, and
Okay.
even with TSMC, I mean, they have things like density rules, and if you're within a couple tenths of %, they'll waive them, but they are rules and they do require a formal waiver.
Yeah.
And then there's other guidelines that, you know, it's up to you. If you don't follow it, your chip's not gonna perform, but that's your problem. You know,
Yeah.
they're manufacturing, and as long as you follow the rules, they'll manufacture it.
Yeah.
Yeah, exactly what I was thinking, Tony, is that right, really the hard things are the manufacturing rules, right? You cannot bend those. And but in terms of guidelines, those guidelines are not necessarily right, they're just guidelines, right?
Yeah, well, maybe we should have for guidelines define a class, right? You know, electrical, thermal,
but usually
liability, whatever. You know, maybe user define, you know, class of guidelines.
yeah, so here's what I'm thinking, right? There's hard requirements both for manufacturing the substrate or the interposer, right? Those are their hard manufacturing rules. And there is the IP itself will have hard electrical rules that say this is the jitter and the I that you have to meet and so on, right? The guidelines are really basically assuming certain technology, you could do this, right? And the intent really there is to save the users of this IP sometime in trying to discover where is their starting point. But in reality, right, the designers would look at those guidelines kind of from informational point of view, and then they'll load the actual rules and figure out what is it exactly that they have to do for their given case, right, to meet the hard requirements, right?
Yeah, you're well. I think maybe there you're starting to encroach a little bit on the electrical Jet 30 model, because that's where you have electrical characteristics, but you know they could be rules as too, like ESD type stuff. So you know these are more physical rules that we're talking about. When you get into these other rules, you know, we already have a mechanism for electrical, right?
Yes. Yeah, and the electrical rules are basically limits, right? This is what you have to meet, right? You could be better, but you cannot be worse, right?
Yeah. Like
right.
The DDR4 can have a trace length of a couple of inches, but a DDR5 or a DDR6, you have to be less than 1 inch long. So that's a hard and fast rule, but it doesn't say you you can be half an inch, 3/4 of an inch, but you can't break 1 inch.
Yeah, even the length, right? There's it's kind of complicated, right? You could again, I consider the length again as a guideline. You could be longer that you know, if you could meet the electrical performance, right? There's nothing preventing you from doing longer.
Right.
It's just a guideline. So
it's a data sheet, and they'll guarantee that performance, or they'll make recommendations in order to use this. This is what we recommend, but at the end of the day, you know, they may have much lower requirements where they're perfectly willing to do that. And you know, we're running at a lower speed or whatever. So
yeah,
and so you want to distinguish those type of rules differently from the must comply with rules.
Of course, yes. To me, the guidelines fall into the thinking of the CDK. They fall into the category of documentation that needs to be provided by the owner, right? The same way you have IP integration guidelines that kind of tell you what is a good way to hook up the IP at the top level. Same thing for chiplets, right? You're gonna have integration guidelines that kind of tell you what is a good practice, but it's not the law, right? That must be obeyed.
Yeah.
So those fall into the PDF, into the documentation part of CDK. I don't think that we are gonna.
Yeah, I mean they do, but some of those integration guidelines, things that are more quantifiable, could be made, in a machine readable format.
So
but that's outside of ADK. Assembly Design Kit.
Yeah,
is very clear. It has to do with assembling these components and the rules associated with that. Electrical is a totally different space, and that's getting very domain specific to the and it's really the active chiplets, right? So that's part of the CDK, the chiplet model itself. So that's
right
outside of the scope of these ADKs and 3DKs. Those are really artifacts of the CDK, the chiplet design kit.
So when a user is writing the rules for one use case versus a different use case, can a specific rule be mandatory for one use case and optional or a guideline for another use case?
Well, who are we talking about? Are we talking about a chiplet or some other non-chiplet component? A passive.
I would be talking about either, right? Because remember, we're designing a structure so that the structure can apply to multiple different use cases. So if we have a process assembly set of design rules, I'm saying if let's say Global Foundries and Micron are dealing with a handover of rules from one to the other, in that scenario, could they say that all of these rules in the PADK are going to be mandatory? Whereas if you go to an Intel process, they could say all of these rules, no, they're only just guidelines. Can, depending on the different use case, can specific rules change from being mandatory to optional?
Yeah, I think the general answer is yes.
Okay.
Yeah,
so
I would. The way I would think, Michael, about this is all rules are mandatory, but they don't have to be exact same set of rules between different vendors, right?
All right. The rule values may be
Not
different.
Not only the values, but the set of rules could be potentially different. Right?
Yeah, and that I'm okay with that, David. That's not the question I'm asking.
But once the rule is there, it is mandatory, right? So the vendor of those rules will decide what rules matter to them, and they'll tell you this is exactly what you have to meet. I don't see things like optional rules, right? If it's optional, why would I do it, right?
Right. Okay. So that I kind of what you just said now is would simplify the schema a bit, because we could have in the schema an optional elements that as soon as you go into that element, everything becomes mandatory. So if you don't want it to be a mandatory, you simply don't specify it, as you said. If you specify it, it is a mandatory rule that you have to comply with. So that type of structure in a schema is very easy to do. But if you say that sometimes I give you a rule and I want you to take this rule XYZ, and I want you to use that rule as a guideline, not as a mandatory, that requires a different schema change. Now I have to put a flag onto that rule and say, is this rule a mandatory rule or an optional rule? And that's the question I'm trying to decide here.
The way, so if you ask, okay, now if you ask the question like that, I think the way we should structure the rules is you put in the flag with probably a severity flag that says what is critical, what is an error that can be waived, and what is a warning that hey, this is not good, but if you really want it, we'll do it for you, right?
Okay.
And maybe the last one is just informational rule, right? Where I don't know.
Okay. All right. So
Right, just provide one flag like that. It's difficult to right. What me and Tony are saying is probably in 99 in the majority of cases, the rules will be mandatory, right? But I'm not 100% sure that every single time there will not be anybody who will say, "Hey, can I make this rule optional?" Right? I think it's a good
Right.
practice to provide that kind of option.
So shouldn't we
Okay.
do like if all rules should be mandatory and then you have to take a specific waiver, like instead of making it optional, like a waiver, so that it's more like not any engineer can just waive it.
Yeah, I
Well,
think that's a good point on the waiver, and that's typically a process decision, right? I would guess that even if a rule is made fatal and mandatory, and there is only one like that, you could still ask the vendor, "Hey, here is one part here that looks that's totally it's a fatal error, but can you please waive it?" Right? And they're gonna look at it and say, "Yeah, okay, this one is okay." Right? We have done
Yeah.
that. Right.
And
all right.
the risk is
So in
yeah,
your
go ahead.
flag that you mentioned, David, you could have critical. Then you could
Error.
say requires waiver, right?
No, the way I would do it is the way I would do it is have 4 levels: critical, error, warning, and informational. Right.
Okay.
And the idea is right. Again, this rule. These rules would be used in both ends of the flow, right? To design things and to verify things, right? So making a rule critical would, in theory, inform the tools that they have to work really hard to meet that rule, right? While for verification, right? So the tools will work hard on the critical rules, maybe a little bit less hard on the error rules, and on the informational one, they could meet it, but they don't have to. Right. Right. On the review, once you go to the other side of the at the end of the flow, you would verify with the same rules. Now you could again ask for waiver, but again, that is a process decision.
Yeah.
Yeah, that sounds reasonable. I'm thinking about a particular example. What about a case where the thing would be manufacturable given the design you have, but it would likely warp soon and have broken connections as a result? If there are rules or guidelines that would prevent that warpage or catch things that would lead to that warpage, what would you consider those? Would those be something you'd be considered critical or what?
Mm. So we haven't actually talked about where does warpage fall into this, in the sense that I understand how warpage is measured, right? It's simulated, and you get a nice picture. And then part of the problem is actually we did have a discussion with one of the OSATs, and the way it works is really the decision about warpage, since it impacts assembly. That is up to the vendor to figure out if this particular design warpage can be dealt with for assembly purposes, such that it produces good design. Right, all the work is basically done is done on the OSAT side, right? Because it involves understanding of the details of the manufacturing process, something that the designer would not be necessarily privy to, right? So typically there would be a couple of iterations, right? Maybe at the design step, you would have a desired floor plan, and you really have to give that to the OSAT and ask them, hey, if I design it like this, can you assemble it? And then they'll figure out what their steps are, right? Because they need to figure out temperatures, what their machinery is like, what the size of the substrate is, all of that stuff, right? They'll take a look, and based on their experience, they'll tell you, yeah, this is okay, or they'll say, no, this is not okay. Here's some warpage, and we need to do steps like so and so, such that it meets warpage, right? Maybe they need to add a stiffener with a given size that will mitigate the problem, right? And again, on the sign-off side, the OSATs have a JEDEC spec that they need to guarantee a certain flatness of the bumps. Right. So when they look at the warpage and their process, they'll say, okay, we can manufacture this and meet our meet the JEDEC standard. This is not in the designer's control. Let me put it that way.
Yeah,
Okay.
I think David, you mentioned it right. I just had a few comments for your reference for Mark. For example, just like the substrate, for example, for the FCBGA, just like the substrate body size. If the body size, we need to define the incoming substrate warpage. For example, if the package size is around 35 by 35, maybe we need to define the bare warpage must less than the 6 mil. But if the package size over than the 50 by 50, maybe the incoming warpage will be defined by 8 mil or 10 mil. Otherwise, substrate supplier need to use their low CT high modules material to do the improvement before providing the substrate to assembly. And after doing the assembly process, as David mentioned, also has the JEDEC to define the output. I mean the finish whole assembly process. We need to control within maybe for the large package, we need to control less than the 8 mil, then ship the sample to the PCB supplier for their second level mounting process. To something like that, we will depend on our capability to define the rule once before assembly or after assembly. So yeah, it just depends on the capability and our lesson learned to define it. And in the assembly process, once, for example, once we receive the big fan-out module, then we do the simulation in advance and find out what's the warpage. Maybe assembly side need to use the recipe over the dedicated tool to control the warpage to ensure the quality is no problem. It's the comment for your reference.
Yeah, that's a good point, Roger, because you know, you can call it a rule, but unless you simulate it, you know, even if you meet the rule, it may not work. So that's why I think a guideline is more appropriate for some of those types of rules.
Actually, Roger, thank you for clarifying this. This is very useful. I wanted to ask you a couple of follow-up questions, right? Warpage has many definitions, right? Depending on the context. So when you say the incoming substrate, do you mean that that you have some limit on a bare substrate at a given temperature, what the warpage of that is?
Yeah, you should.
I mean, right, it's the condition that I'm trying to focus on. Is it possible to define something like that? Hey, a substrate without any components at a given temperature,
That's
the warpage must be this much.
So that falls into like a reliability rule, right? So it's not an assembly rule. I mean, you're following these assembly rules and guidelines in order to ensure you're going to have a manufacturable, reliable design. But at the end of the day, it's a guideline to help you you know, achieve that particular reliability requirement. So I think
It's exactly the same as a coplanarity on a QFP. If the coplanarity, there is a specification for the maximum coplanarity you can have on a component. And if you break that, then the consequences are when I go to do the assembly, it's not going to make the join to the printed circuit board because the gap is too big. It's the same concept with warpage. It's the warpage concepts of putting a large device, a large BGA device especially, onto a warped PCB is no different than putting a die on a warped interposer. If the interposer fails its rules, then the assembly is going to have a knock-on effect with the assembly.
Yeah, warpage is mentioned in the BGA site, and which will related to the assembly handling issue. And for the coplanarity, we always call it in the C4 area, just a bump and a pre-solder connection area. Yeah, it's very important. Normally, we need to control the coplanarity less than 20 to 25 micron. Yeah, due to the once no matter use the TCB or use the mainstream flow, we need to control this coplanarity criteria less than 20 to 25 micron to ensure that we can get the good bump joint quality.
Yeah. So Roger, are you saying that you can define an upfront rule that says that either the entire substrate could warp by this much, or where the chiplet BGA is, the limit for warpage is this much. I'm assuming that's at a given temperature. Basically, define an upfront rule that a designer can take that rule and run automated checks.
Let me share information for your reference. From the product development procedure, for example, just like our IC, our customer IC design house, they will have the substrate drawing. They will have the substrate drawing and send to OSAT to do the review firstly. Then they will once we confirm this rule, for example, we need page size is the 50 by 50, and then we need to control the community less than 1 mil and the YBG less than 8 mil. Then we'll ship this substrate drawing to the substrate vendors. I mean, even the 1 or 2 or 3 substrate vendors. Then substrate vendors will review this drawing again, then provide a comment. If we align it, the substrate suppliers will follow this criteria to do the manufacturing.
Okay. Yeah. I understand this, but the way I understand it is basically you have to have the substrate done, and only that and then the review is can happen. My question is on the other side, much earlier on, before we actually start the design, is there a rule that we can follow to design to ensure, right, that says whatever we draw, if it meets that rule, we are good to go?
Yeah.
Or is the review process fully custom where in one case the same dimension, how do I say, where basically in different cases you may have different values and still have a workable substrate?
So I've seen a situation where people do a design and they say, because of the components that I'm putting onto the design, I require a flatness ratio of this amount. And that flatness ratio might be tighter than what would be accepted by the industry for a typical type product. So that's also possible. So you can specify on an interposer when it is being designed that the flatness requirement on this is at a certain level. And let's assume that it's a 0.8 millimeter, right? And that the standard was less than 1 millimeter. Well, you might say, well, we're putting certain dies on it from Micron that needs to have a flatness requirement of less than 0.8. So now the interposer manufacturer has to put in additional control processes to ensure he meets that guideline.
Roger, what's your view on this?
Yeah, I think Michael mentioned is right. Then the other one is the customer always provide a POD. We call it the package outline drawing. We will define the related dimension and the minima or maxima are high and the a lot of the criteria. And we must follow this POD to think about how to process or how to work with the substrate supplier or the component supplier to meet the customer's POD requirement.
Okay. So the way I understand is then this is a little bit of a negotiation process where based on content and materials and manufacturing process and assembly process, the limits will be derived based on that, and then the design can happen with those. It's not set in stone value that must be met ever. It doesn't matter what you do.
Yes, correct.
Okay.
So this becomes a very good example as to why we are suggesting integrating the design rule kit in with the part model, because Micron, who's producing a part model, might say, I require a flatness on my interposer of less than 0.8. Then when the interposer rules comes in and he says, I have a flatness requirement of less than 1. Well, now your systems can automatically check to see that, hey, we have a component that requires this, but the interposer is not meeting it. We have a potential reliability type problem.
Meeting the flatness on the interposer is a design constraint. It's not necessarily a right? Some of the warpage can and will be mitigated by adding stiffeners and things like that, right, to meet that rule. But see, here's the thing, right? Maybe my micron says I want 0.8, but the assembly process can come and say, well, it's great that they want 0.8, but for our assembly process to work, we need 0.6, right?
Yeah.
So, and that value 0.6, it's derived based on review of the entire design, right? Not component by component.
Yeah, that's true. Now, if the 0.6 is not going to cause a problem to reject certain components, obviously it won't, right? But let's assume there was a different type of rule that it did. Then you don't have a problem, because now the system will look at all of these individual rules and say, which of these, for the same rule across different sources, which of these sources gives me the tightest constraint? That becomes the constraint that you have to comply then through your design.
Okay, yeah. Let me say what I understood from Roger. The 0.6 rule is not a manufacturing technology or manufacturing process limitation by itself. 0.6 rule will come from combination of manufacturing capability and design content, right? So until you have until you have a design in mind that you can give to the manufacturing house, to the OSAT, to take a look and tell you what their capabilities for this particular design, you don't know whether it's 0.6, 0.5, 1, 5, whatever, right? Roger, did I understand you? Is my understanding correct?
I think yes. I just quoted one example. For example, maybe 5 years ago, the minimum pitch, we always say that the minimum pitch is the 50 micron. Now customer request to have the 30 micron. It's out of our capability. So assembly side need to develop the new technology, just like they maybe use the hybrid bonding to replace the TCB or mass reflow. It's the other topic, you know.
Yeah.
Yes, but we need to understand what's the minimum pitch is customer wanted for this product. That's why I mentioned we need to have the POD to know the related critical dimensions. Then we need to define these critical dimensions as the check item. Then we have the general rule. I mean, the general rule means the you can use the mature process for the mass production experience. It's the general rule. Once out of the kind of this rule, for example, we got a lot of the advanced product devices recently. We need to item by item to check the related dimension. We call is the gap analysis to see is there any gap for this product. Then do we have any solution to reach the goal? So we need to define the guideline and the critical dimension. I think it's enough, but maybe we cannot show the actual number for them.
Yeah. So Michael, what the way I understand what Roger is saying is that really the assembly process is basically driven by the design, right? And how the assembly gets done and exactly processing steps and so on would be design driven. So
right. So
there's handshake that happens between the designer and the OSAT to figure out, right? The OSAT will figure out what the process is, and the designer will figure out how they keep warpage or distances to a certain level, right? But it's not the way, right? The best example of us set in stone rules would be PDKs for silicon, right? You have the wire width, the wire spacing. That's it. That there's nothing you can change in any of that, right? That's a fully set general purpose process.
Yeah.
Right. So in that context, I don't see how upfront. I understand that a chiplet vendor may have some view into the warpage and kind of recommend something, but outside of that, I don't see how there could be an upfront rule that says this is the limit.
Yeah, it seems like what you're saying is that in the case of a PDK, it's a contract that's understood up front. And in the case of things like this warpage, there's so many options that it's hard to have such a contract up front. It's more like a negotiation as you go.
Yes, right. It's
If you take a large area array die and the manufacturer of the die says that if you bend that device beyond a certain number of microns, the device is going to crack. Let's say that, right? So that becomes a hard and fast rule that the assembler has to adhere to if he doesn't want to run the risk of having cracked dies. And that's not a negotiation point. That's a hard and fast rule that Intel or Micron are saying. If you go beyond 25 microns, you're going to crack my device. So we say don't go beyond this limit, and that's it, period. So sometimes you have a negotiation, and sometimes you have hard, fast rules.
Yeah, it gets a little more complicated than that, because oftentimes the assembler may thin the device, grind it down so you have coplanarity. So maybe the way it comes delivered as the component, if you thin the substrate, then those rules change. So there's some of those rules would have a variable,
I think at the
out
end
of
of
the
the day,
box,
guys,
this is the rule, but if you make it thinner, there's a difference.
Okay. I think Michael, so what Michael is mentioning, that's not necessarily that's a reliability rule, right? Obviously things can be assembled, right? For whatever reason, say we were able to assemble it with whatever tolerances. What Michael is saying is that if you bend the die this much, it's gonna crack, right? So hypothetically, if there's a vendor that ships basically singulated dies as chiplet and bumped, they could specify that. I have one thing that comes to mind is that is a ADK definition, right? The TSMC will tell you if you bend any die beyond this point, it will crack, right? So that is a
it's a design constraint. It's a design constraint.
But again, the chiplet vendor has no way of knowing really once you put it in the substrate how far it will bend. So maybe I do see a little bit of a point in specifying at the chiplet level what is the maximum warpage that this chiplet can tolerate? And I'm assuming it's not, it's probably with, I mean, size of the chiplet dependent, right? Because large chiplet, if it's, let's say if it's 20 by 20, it will bend 25 microns and it's going to be okay. If it's 2 by 2, 25 microns is too much, right?
Yeah, and that's why those type of rules are constraints that are imposed by the manufacturer of that component on the assembler side. So all of these complex rules should be taken down to a micro level and then partitioned to who defines that rule and why is that rule important to the person that's defining it. So in the case of a chiplet warping, Micron has to define that rule because they say they're responsible for the reliability of their chip. The assembly person who puts the chips onto the assembly, he defines a set of rules, but he's responsible for the assembly. He's not responsible for the individual die, but he has to comply with all of the requirements that the die imposed on him. And the same concept works all the way up.
Roger, what have you seen in this context? Have you seen limitations for different chiplets? What is their maximum warpage that they can tolerate? Or is that generally large enough value that basically the limitations of the assembly process take care of those?
You mentioned the chip, the die?
Yeah, basically what Michael is saying, if a chiplet, have you seen cases where chiplets come in with maximum warpage requirements that you had to explicitly meet? Or is it the case that the assembly requirements are much tighter than that? The assembly process requirements are much tighter than that. So the warpage of individual chiplets never really comes up and it's automatically met.
Okay, I will separate two portions to discuss this topic. The first one is the if is the bare silicon wafer always the 12-inch and the thickness general is the 31 mil. So it will not have the warpage concern due to they will shift the wafer form to assembly. Then we do the lapping by ourselves to control the warpage. Is the first portion. The other portion is just like the fan-out module. The wafer form already combined the lot of the chip module in the wafer form. Then we need to do the assembly. So assembly process maybe to do the RD or layer for the further connection. Then for such kind of the samples, we will get the inner design to do the simulation firstly to know the warpage performance. Then we will have the special tool to handle it once during the assembly mounting process. You got my point?
Guys, we're at the top of the hour, so clearly these rules or guidelines are kind of persona based. So if it's in a manufacturer, they will have manufacturing rules, and they will have some environment constraints or rules that you must follow. Those are manufacturing related. And then you have the analysis type rules. In this case, we've been talking a lot about physical. So those are rules that really would be defined by the assembler. So I would consider those are assembly design rules. But they can tell you what the rules are, and then those rules would be then verified through simulation. So It's not like we can create a checker that says, yeah, this is a checker. You know, it's a simulation. So it's different than a physical rules. So
Yes.
The first set of classes, you know, these are you know, this is what we can build, right? So there's a min-max, you know, pitch for bumps and bump sizes, you know, these connectivity rules that are going to be put on the interposers and the top level bumps of the die. And so we need to, you know, as you're doing a design, you will have to look at all the different suppliers of those components and make sure you come up with a common set of rules for those connectivity components that are manufacturable. Now, that doesn't ensure it's going to work, but at least that's a minimum requirement. You have to make sure that if you're doing a design, you know, wherever you're getting those components from, the manufacturer, you're meeting their manufactural limits. And then, you know, there are design specific targets that need to be met. And, you know, some of them may be coming from, and I think really whoever's doing the assembly is going to have a set of rules. So that is, you know, a set of rules that are not necessarily related to the manufacturer, but you know, it is a design constraint. So and then there's electrical type rules. So I think, you know, these rules need to be put in these different categories, and you know, the company or the design entity that is defining these rules should be probably in that schema, so we know where the rules come, so we have source, and then when we do the analysis, maybe somehow whatever design company did the analysis may have to annotate the actual results, you know, so there is a burden of proof for the designer to make sure that these rules were complied. So for physical rule, that's pretty straightforward. You have rule checkers, and you have the rule deck, and that's satisfied. For other types, you're going to have to do simulations, and then those simulation results need to be documented. And then, you know, we want those results rather than in the PDF, you know, have those results with you know, the results of that simulation or that analysis in machine readable format, so we can go back and look at the source of where that analysis was done. So you know, there's an electronic log, if you will, of you know, proving that these rules or guidelines were met. So we're gonna have to wrap up here. We're already we're running. We're late on our next call, but good discussion. In short, I think we need to focus on these manufacturing connectivity rules, and then we have to continue the discussion to figure out how to structure and where to put these other rules. Are these all going to go in the same document, or do we have a set of documents? I think there could be one overall spec, but we need some different nomenclature, and so more work to do, but good discussion. Thanks, everyone.
Yeah. Sounds good.
Thanks.
Yep.
Thank you, guys. Bye.
Bye.